Hello, everybody. We are back with another visual pattern challenge. So in this challenge, you're supposed to look at this visual pattern. Here's step one, here's step two, here's step three, and use your insight and your intuition to figure out how many helmets in step number four. And then much more difficult, how many in step 43, and can you write an equation that could be used to figure out the number of helmets in any step at all? This one I think is pretty difficult. So if you'd like to accept the challenge, pause the video, give it a try, and see how you do. All right, well, let's see if we can figure out what's going on in this pattern. One thing I notice just looking at it is that it gets bigger really quickly. So my first guess is this is not a simple linear pattern. It looks like it's getting big so fast it would have to be an x squared and a quadratic or something like that. Maybe not a quadratic, but something along those lines because it's rapidly getting to be a lot of helmets. Look how many in step number three. And let's look at the pattern here and see if there are any things I can notice. I guess one thing I'm noticing is in step number one, there's one row. In step number two, there are two rows. In step number three, there are three rows. So I guess I would expect in step number four for there to be four rows. And then the length of those rows, let's see, there's three here, and this is five, and this is seven. So it looks like the length is going up by two every time. So if this is 3, 5, 7, this should be 9, right? So we'd have four rows of 9 helmets, and that would be 4 times 9 is 36. So our prediction for step 4 should be 36. Would you agree with that? We'll test that later. I think to go beyond this, to try to get to step 43, we have to write an equation first. It's just too going to be too complicated and messy to count that high. So let's start by analyzing our numbers. I'm going to make a chart with the step number and the number of helmets, and we'll see if we can figure anything out from looking at the numbers. So in step 1, I've got 3. In step 2, that's 2 times 5 is 10. And in step 3, that's 3 times 7 is 21. And in step 4, we're predicting 36. So I'll put that in as well. Once you've got your numbers laid out in a chart like this, the next step in trying to understand what's going on in a pattern is looking at the difference between steps. So this is how much it changes by. 10 minus 3 is 7. 21 minus 10 is 11. And 36 minus 21 is 15. So this set of differences, it's not constant. The amount it changes by changes in every step. So this is not a linear pattern. At this point, we usually take the second differences. So 11 minus 7 is 4. 15 minus 11 is also 4. If you get a constant number there, you know you're dealing with a quadratic. So x squared is going to be in this somehow. So when the difference of the differences is a constant, we've got a constant of 4. Somehow it's going to be a quadratic. How exactly? So if we look at step number 1, we've got 3. X squared would just be 1, right? So I guess this could be 3 times x squared, or maybe it's x squared plus 2, right? Because that would be 1 plus 2 would be 3. So maybe it's one of those. We can take those guesses and try them with step number 2. Let's see. In step number 2, we'd put in a 2 for x. 2 squared would be 4 times 3 would be 12, but we've got 10. So that's too much. Let's try the x squared plus 2. 2 squared is 4 plus 2 would be 6. Well, that's not enough. So it's neither of these. Let's go back to the actual pattern itself. I'm going to choose a different color here. And I think I'm going to ignore step 1 for a minute, and I'm going to look for patterns of x squared. The reason I'm ignoring the 1 is because 1 squared is 1, so it gets confusing. It's itself, but 2 squared is not 2. So here's a 2 squared, right? That's 4 helmets. Here's another 2 squared, and there's 2 left over. Okay, let's try that same thing in the 3s. Here's a 3 squared. Here's another 3 squared, and 3 left over. That looks like a pattern to me. It looks like you have 2 of the step number squared plus the step number, right? So this is 2 in step 2, this is 3 in step 3 that's left over. So let me switch my color back here. This would be x squared plus x. So let's just plug some stuff in it and double check that that actually works. So that in step 1 will be 1 squared plus 1 squared plus 1. Well, that would be 3. Here in step 2 would be 2 squared plus 2 squared plus 2. That'd be 4 plus 4 plus 2. That would be 10. Yeah, and 3 squared, 9 plus 3 would be 21. And let's double check on step number 4. So that would be 4 squared plus 4 squared plus 4. So that would be 16 plus 16 is 32 plus 4. Yeah, that equals 36. All right, I think we have this. I think this is our equation. So we'll jot that down here. And there are lots of ways to write this. I'm going to write it as 2x squared because we have 2 of the step number squared plus the step number. So now we can use that to figure out how many in step 43, and it's going to be a big number. So y equals 2 times 43 squared plus another 43. Guess I didn't need that parenthesis. So let's see, 43 squared is 1889, and we multiply that by 2. I think we're getting 3698 plus 43, which would be 3741. I think that's correct. That's a lot of helmets in step 43. Well, how did that one go for you? Did it stump you? Did you get it? Did you at least get step number 4? Let me know. Thanks, everybody.